Welcome, everyone. Today, we're going to look at the blueprint for a digital skyscraper. We're breaking down the fundamentals of core Java, which is the incredibly powerful programming language behind some of the biggest applications you use every day. So, have you ever really stopped to think about this? How in the world do developers build these gigantic digital structures that millions, even billions of us rely on? I mean, it seems almost impossibly complex, right?
Well, the secret is to stop thinking about it as magic and start thinking about it as engineering. You build it piece by piece following a solid plan, just like a skyscraper. And today, we're going to explore the architectural blueprint for one of the most reliable and powerful construction materials in the digital world, Java.
All right, so every single great construction project, whether it's a bridge or a building, starts with the fundamental components. Before we can build up, we got to understand what we're building with. It's all about laying that solid foundation. And here they are. These are the absolute non-negotiable building blocks. Think of them as the bricks, the steel beams, the concrete of our program. These primitive data types define the most basic kind of information we can work with. You know, things like numbers for a salary, a single letter for a grade, or a simple true or false. This is the bedrock of everything else we're going to build. Okay, so once we have our materials, where do we actually put them? Well, we store them in variables. The easiest way to think of a variable is just as a labeled box on our construction site. So this box here, it's named salary. It's designed to hold a whole number, an int, and right now it's holding the value 50,000. It's really that simple. It's just about staying organized. With our materials all sorted out, we now need a plan of action. In programming, we call this control flow, and it's basically just the set of instructions that tells our program what to do, what decisions to make, and how to react as it's running. Now, a huge part of any plan is making decisions on the fly. Java gives us a couple of great tools for this. The if-else statement is kind of like your site foreman making a judgment call. If the ground is wet, then we do this, else we do something different. A switch statement, on the other hand, is more like a checklist. You have a fixed set of known options, and you just pick the one that matches the situation. You know, construction involves a ton of repetitive work, laying bricks, installing windows, floor after floor. Programming's exactly the same. Loops are our power tools to automate all that. Need to build 100 floors? A for loop is perfect, because you know the exact number. Need to keep drilling while you haven't hit solid rock? Well, that's a while loop. And if you just need to go through every item in a list, a for each loop is the quickest way. It's all about working smarter, not harder. Okay, let's zoom out of it. We're moving from the basic construction plan to the master architectural design. This is object-oriented programming, or OOP for short. And honestly, this is the stuff that lets Java build those truly massive, stable, and maintainable skyscrapers. This right here is probably the most important idea in OOP, so let's break it down. A class is the detailed blueprint for something. Let's say a skyscraper. An object is the actual physical skyscraper you build from that blueprint. And here's the key. You can use that one blueprint to build millions of unique skyscraper objects. Now here's where things get really clever. This is called inheritance. Why design a whole new skyscraper from scratch if you can just inherit the foundational design of a standard office building that's already proven to work? You take an existing blueprint, or a class, and you just extend it, adding new features while getting all the old ones for free. And that leads us directly to the single most important benefit here, reusability. You're not reinventing the wheel for every single part of your application. Instead, you're building on top of existing, tested, reliable code. This saves an absolutely incredible amount of time and really cuts down on potential mistakes. Polymorphism, okay, I know, it sounds like a big, complicated word, but the idea is actually super simple. It just means many forms. Think about a start button. That same instruction works very differently if you're starting a car versus starting a computer, right? Same command, different context-appropriate results. That's all polymorphism is, and it makes our designs incredibly flexible. Every good building has secure areas. I mean, you don't want just anyone wandering into the main electrical grid room, right? Encapsulation is exactly that for our code. It's the practice of bundling the important data, like the electrical wiring, together with the only methods that are allowed to control it, like the light switches, and then hiding all those complex internal workings from the outside world. And the key benefit here is pretty obvious. It's all about security and control.
Encapsulation is what protects the critical internal data of our application from being accidentally or maliciously messed with by other parts of the program. It's a foundational principle for building safe and robust software.
When you get in your car, you don't need to understand how the internal combustion engine works to drive it. You just need the steering wheel, the gas pedal, and the brakes. That is abstraction. We hide all the messy, complex inner workings and just provide a simple, clean interface for the user. It's what makes complex systems easy to actually use. All right, our building is designed. The structure is sound. But a skyscraper is way more than just a shell, right? It needs safety systems, storage rooms, and all the utilities to actually be functional. So what happens when something goes wrong? Because, things always go wrong. What if a small fire starts on one floor? You certainly don't want the whole building to collapse. Exception handling is your building's automated fire sprinkler system. It catches errors, or exceptions, as they happen and deals with them gracefully so the whole program doesn't come crashing down. Our skyscraper also needs places to store and organize things. People, data, equipment. The collections framework in Java gives us all of our storage solutions. A list is like a tenant roster, perfectly ordered by floor. A set is great for things like employee IDs, where you can't have any duplicates. And a map is like the building directory in the lobby, linking a key, like a room number, to a value, like the person who lives there. Okay, we are almost there. We have the materials, we have the architectural blueprint, and we have the safety systems in place. Now we need the construction foreman, the project manager, who makes sure everything actually comes together perfectly. In the Java world, that foreman is very often a tool called Maven. And Maven's job is really twofold. First, it completely automates the process of actually building our application. And second, and this is absolutely crucial, it manages all the third-party materials, the specialized windows, the custom elevators, the specific brand of steel that our project depends on. So how does Maven know what to get? It reads this one file, the pom.xml. This is the master manifest for the entire project. Just think about how many specialized parts a skyscraper needs. Trying to manually find and manage all of them would be a nightmare. Instead, you just list them in the pom.xml, and Maven goes to a central warehouse on the internet and downloads everything for you, automatically. It is the single source of truth that makes modern development possible. So there you have it. From the simplest data types, the bricks and steel, all the way up to the grand architectural patterns of OOP and the project management of Maven. That is the blueprint for building a digital skyscraper with Java. The foundation has been laid, so the only question left is, what will you build?